Dear students, welcome to the second part of the real number exercise number 1.2. Let us go directly to the questions. Question number 1. Express each number as a product of its prime factors. So let us see the answer here. So all these 5 questions are marked here as one. Here the first question is 140 and its factors are mentioned here. See how I think all of you know what is a prime number and a composite number and how to factorize. Here 140, suppose we are factorizing 140, so it will be like here if you divide by 2, 70, again divide by 2, it is 35, so again divide by, again here we are dividing by 5, so it is 7. So 2 into 2 into 5 into 7, that is 2 into 2 into 5 into 7, that is the factors. So similarly second, third and fourth questions, if you divide like this one, you will get it. Let us go to the second question. Question number 2. Find the LCM and HCF of the following pairs of integers and verify that LCM and into HCF is the product of two numbers. Here let us take the first question. Here 26 and 91. As you know, in the exercise number 1, HCF is equal to, using this HCF is equal to 13. Then next LCM we are finding 2 into 7 into 13. So I think you know how to find the LCM. For example, here 26, 91. See how to do is, here we are dividing, this is 2 and 13, and this 19 we are taking as it is. Then again we are dividing, this is 13 one time, then 7 times. So 7 into 1 into 13 into 2 means 2, 7, 13. So after multiplication you will get 182. So if you multiply these two numbers, you can see here product of two numbers are this one, 26 is 91, that is HCF of these two numbers are 13 into 182 here, that will be, so this one and this one both are equal, so hence the product of two numbers are HCF into LCM. Similarly the second question, here also we are finding the HCF first and LCM. Here HCF into LCM is equal to this one. Later product of these two numbers is this one, so both will be, here you can see the both will be equal. So that is clarified here. And the third question, the same procedure, you can see here HCF and LCM, and product of these two numbers is equal to this one, and this one is here, so both will be equal. Next is find the LCM and HCF of all integers by applying the prime factorization method. Let us see, this is the first question here, 12, 15, 21. Factorization, 12 is 22 into 3, 15, sorry, this is 2 to the power of 2 into 3. This is wrong, this means 2 here. and 4 into 3 12, and 3 into 5 15, and 21 is equal to 3 into 7. Here you can see this is the HCF. I think all of you know the HCF is, we find the exercise number 1 how to find the HCF. Here the least powered common factor, that is 3, so it's HCF, and LCM is of 3 numbers, that is I explained earlier, 12, 15 and 21. So dividing 2, so it is 6, 15 and 21, again 21, again we divide by 2, so here 3, 15 and 21, next we divide 3, here 1, 5 and 21, sorry 7 to 3 is 21, so 7 into 5 into 3 into 2 into 2, 2 into 2 into 3 into 5 into 7, that is 420. So let's go to next, the product of this. Similarly this one, HCF and LCM. HCF is equal to 1 and LCM is this one. Here the HCF is equal to, and LCM is equal to question number 4. Given that HCF equal to 306 and 657, that is equal to 9. Find the LCM of this one. As earlier we see HCF into LCM equal to the product of two numbers. So the product of these two numbers will give, here the HCF is equal to this one, product of two numbers will be this one. So how can find the LCM? We know that the LCM and HCF of product of two numbers, hence the LCM into HCF equal to this one, and LCM equal to divided by HCF, this product of these two numbers divided by HCF, so it will be this one. So using this one we can find the LCM, means LCM and HCF, if we have multiplied both of these, both LCM and HCF of two numbers, you will get a number. That number will be the product of these two numbers. Then any of the number will be not available, you can find the other one. And next question, check whether the fifth question, check whether 6 to the power can be ending with the digit 0 for any natural numbers n. Solution. You can see here, let us find the prime factorization of this one. That will be 6 to the power n is equal to 2 into 3 to the power n, means 2 into 2 and 3 are factors of 6 to the power n, and 5 is not a factor of. So here 2 and 3 is equal to 6 and n is the power. Okay, and 5 is not the factor of this one. For any value of n, 6 to the power n will not be divisible by 5. So for the clarification, you can see if any number ends with the digit 0, then it should be divisible by 10, or other words we can say it will be also divisible by 2 and 5. Here 5 is not a factor. So 5 is not a factor means it is not divisible by 5. Therefore 6 to the power n cannot be end with the digit 0 for any natural number n. So the statement is true. Next question is explain y and our composite number. These two are composite number. Why? The question is why. So let us see how to solve. As we know, the numbers cannot be classified prime and composite numbers. A prime number can be divided by 1 and the number itself, but the composite number have factors other than 1 and itself. A number can be divisible by y and number itself. A prime number means 3 is a prime number. 3 can be only divisible by 1 and 3, but 9 is not a prime number. It can be divisible by 3, 1, 3, 9. Here similarly 8 is not a prime number. See, this can be divisible by 1, 2, 4, 8. So a prime number is a number which can be divisible only by, this is a prime number, only by the number itself and 1 only. So but a composite number factors other than 1 and that we explain here. So that means the provided expression is, you can take it as like here, that is 78 into 13 into 13 into 6. The given expression has 6 and 13 as its factors. Here you can see this one. The given expression has 6 and 13 as factors, 6 and 13. Therefore it is a composite number. It's a composite number. Similarly, the next one, five and 1009. It's a factor and it's a composite number. There are two numbers only. Next question 7. There is a circular path around a sport field. Sonia takes 18 minutes to drive one round the field, while the Ravi takes 12 minutes for the same. Suppose they both start the same point at the same time and go to the same direction. After how many minutes they will meet again in the starting point? So in a circular way, both Ravi and Sonia both starts to run from here, but the 12 minutes and 18 minutes they have taken. So you can both so direction at the same time. The method to find the time when they will meet again. Starting point is LCM of these two numbers, 12 minutes and 18 minutes they have taken. So the LCM, we are taking the LCM of these two numbers, it will be 36. After 36 minutes they will meet at the point. Okay, so the second exercise finished, so let us wait for the third exercise. Thank you for watching.